EMV has been implemented in many countries around the world during the past 20 years. Each country has had its own unique challenges during its implementation. The goal of this presentation is to demystify one of the least understood components of the U.S. EMV migration, the U.S. Common Debit AIDs. This presentation was updated in June 2017 after clarification from the Federal Reserve on Durbin compliance. By now, most people involved in the U.S. payments industry are aware that the Durbin Amendment to the Dodd-Frank Wall Street Reform and Consumer Protection Act had an impact to the routing of POS debit transactions. As you can see on the slide, the Durbin Amendment requires that there must be a choice between at least two unaffiliated networks when routing POS debit transactions. If you would like to read more about the Durbin Amendment, follow the link shown here. With the introduction of EMV, industry stakeholders still had to comply with the Durbin Amendment. In addition, industry stakeholders had to preserve the routing choices they have today. It's important to remember that the Durbin Amendment applies to transactions initiated by U.S. issued cards at U.S. terminals, and the Durbin Amendment does not apply to credit transactions or ATM transactions. However, as we will see throughout this presentation, both POS and ATM terminal owners have adapted in order to facilitate a choice between two unaffiliated networks when routing EMV debit transactions. In this presentation, we will focus on debit transactions and what changes with the introduction of EMV. Let's start with a quick review of what is on a magnetic stripe card today. Some of the card components, such as the organization name and logo, are consistent across all of the cards in a portfolio. Some cards are affiliated with a particular card brand or payment network. Some data is specific to an individual cardholder, such as the PAN and the cardholder name. The magnetic stripe on a card does not hold a lot of information, and the information it does contain is static. It does not change for the life of the card. Now let's take a look at the flow of a debit transaction in our familiar magnetic stripe world. Although the U.S. payments infrastructure is very complex, with many potential participants in a transaction, we will use a very simple example to illustrate our debit transaction. In this presentation, we will use the term POS acquirer or simply acquirer to represent the entity that is responsible for routing a transaction. The acquirer could be the merchant or an acquiring processor. We will also use the term issuer to represent the issuing institution or the issuer processor. The cardholder swipes the debit card and the terminal captures track data from the magnetic stripe. The terminal formats a transaction request and sends it to the acquirer. The acquirer then makes a routing decision based on factors such as the BIN, which is the first few digits of the card number. As a result of the Durbin Amendment, a merchant must be provided with a choice of at least two unaffiliated debit networks. In our example, the acquirer can choose between Network A and Network B. For various business reasons, let's say they choose to route this transaction to Network A. Eventually, the transaction request will reach the issuer, and the issuer will make their authorization decision. The issuer will generate a response and send it back to Network A. Network A will forward the response to the acquirer, and the acquirer will then pass information to the terminal, such as whether the transaction was approved or declined. With the introduction of chip technology, a payment card will actually contain a microprocessor, which has many similarities to your PC or laptop. They both have hardware, and they both have an operating system. Your computer can support multiple applications, such as a word processor, browser, and photo editor. Each of these applications supports different types of files which contain data. The chip on a chip card can also support multiple applications, although most U.S.-issued chip cards will initially only contain one application. Each application on the chip is represented by an application identifier, or AID. It is also possible for an application to be represented by more than one AID. This approach is used for the U.S. Common Debit AIDs, as we will see later in this presentation. Each application contains files with data that is referenced by the chip card and the terminal during an EMV transaction. A chip can hold a lot more information than a magnetic stripe. As we noted on the previous slide, for each application or AID on the chip, some specific information is required. This information can vary from one application to the next. For now, each U.S.-issued chip card will still have a magnetic stripe, so that the card can be used at terminals throughout the world that do not yet support EMV. When we say global AID in this presentation, we are referring to an AID that is owned by the global or international payment network whose logo is on the card. Global payment networks include American Express, Discover, MasterCard, UnionPay, and Visa. When a global AID is used for a transaction, the transaction must be routed to the associated global payment network. EMV and U.S. debit bring challenges to the U.S. payment landscape. When that global AID is selected for a debit transaction, the transaction must be routed to the global payment network that owns that AID. How do we preserve the routing choices as required by the Durbin Amendment? What AIDs can be used on cards that do not exclusively carry the brand of a global payment network? The Global Payment Networks and the EMV Migration Forum's Debit Working Committee looked at many possible solutions to enable routing choices where required. The result was the U.S. Debit EMV Technical Proposal, which describes the use of U.S. Common Debit AIDs. The link to the relevant white paper is shown here. This solution is compatible with a contactless transaction when implemented on a dual interface EMV chip card or a mobile device. However, contactless and mobile transactions are outside of the scope of this presentation. Refer to Addendum 1 of the U.S. Debit EMV Technical Proposal, version 1.3, for more information about contactless acceptance and the use of the U.S. Common Debit AIDs. The typical implementation of a contact debit chip card with a U.S. Common Debit AID, at least in the early phases of the U.S. EMV migration, will involve a card with two AIDs: a payment network-specific AID, which we will refer to as a global AID in this presentation, and a U.S. Common Debit AID. Currently, Discover, MasterCard, Visa, UnionPay, and other global payment networks provide U.S. Common Debit AIDs to be used on debit cards with their brand. American Express does not require dual routing. Therefore, American Express cards will utilize the American Express Global AID and will continue to route as they do today. For cards that do not support one of the global payment networks, a shared debit AID can be licensed from the Debit Network Alliance. For more information about the Debit Network Alliance, refer to their website using the link shown here. A U.S.-issued branded debit chip card will typically contain a debit application from a global payment network. There will be two AIDs associated with this debit application: a global AID from that global payment network and a U.S. Common Debit AID from that global payment network. Both AIDs will point to the same funding account. The global AID must be used outside of the U.S. since terminals outside of the U.S. will not support a U.S. Common Debit AID. The U.S. Common Debit AID can be used along with the global AID in the U.S. to facilitate routing choice to both global and regional payment networks. A U.S.-issued card that does not support a global payment network can license the shared debit AID from the DNA for their debit network branded cards. This AID can be used with any debit application that meets the criteria specified by the DNA. At this time, no other AID will be on cards that support the shared debit AID from the DNA. Now that we have U.S. Common Debit AIDs on our U.S.-issued debit chip cards, the problem is solved, right? Well, there's just a little more to it than that. When a transaction is initiated by a chip card at a chip-enabled terminal, standard EMV processing dictates that the terminal must determine what AIDs are supported by the chip card and the terminal. Then, a mutually supported AID must be selected for the transaction by either the merchant via parameters set up in the terminal or by the cardholder. Let's look at how this could work. Here is a sample card and terminal. You can see an example of the AIDs that the card and the terminal could support and how the matching happens. This is true not only for POS terminals, but also for ATMs. Although ATM transactions do not fall under Durbin Amendment legislation, ATMs must abide by EMV specifications, and most will accept U.S.-issued debit chip cards that support a U.S. Common Debit AID or the Shared Debit AID. When application selection happens for the same funding account, the terminal selects the AID based on terminal parameters created by the merchant, preserving merchant selection of routing, and is needed to support the U.S. Common Debit AIDs, and can allow for cardholder choice if the merchant elects to offer it. However, if the card includes two applications for different funding accounts, then the cardholder needs to make the selection. A short description of the AID will be presented on the screen. An example is shown here. U.S. terminal owners and acquirers will need to support multiple AIDs. U.S. terminal owners will need to support a global AID for global payment networks and should support the U.S. Common Debit AIDs in order to preserve routing choice for those same global payment networks and U.S. domestic payment networks, which includes the Shared Debit AID from the DNA. During the interaction between the chip card and the terminal, if the merchant selects the U.S. Common Debit AID, the transaction can be routed to any network that is enabled for the card, either the associated global network or a U.S. domestic payment network. During the interaction between the chip card and the terminal, if the merchant selects the Shared Debit AID, the transaction can be routed to any U.S. domestic payment network that is enabled for the card. Now let's look at an online debit transaction involving a contact chip card and a chip-enabled POS device. The concepts that are described here are also relevant to ATMs. The chip card will be inserted into the terminal and must remain there for the duration of the transaction. In our example, we have a U.S.-issued debit chip card with two AIDs, a Global Debit AID and a U.S. Common Debit AID. In our example, the Visa U.S. Common Debit AID is selected. Logic may be incorporated into U.S. terminals in order to select a U.S. Common Debit AID over a global AID. Details about the U.S. specific logic that will be needed can be obtained from the terminal vendor. The chip card provides some EMV-specific information to the terminal, including an authorization request cryptogram. The terminal formats an authorization request, which contains new EMV data elements, including the authorization request cryptogram, and sends the request to the acquirer. The acquirer needs to make a routing decision. When the U.S. Common Debit AID is selected, the transaction can be routed to any network that supports this AID and that the issuer has enabled for the chip card. This includes Visa networks as well as U.S. debit networks that have enabled the Visa U.S. Common Debit AID. In our example, the acquirer routes the request to a U.S. debit network. Eventually, the transaction request will reach the issuer, who must verify the authorization request cryptogram and make an authorization decision. Now let's talk about the response to our transaction. The issuer will generate a response, which may also contain EMV data, such as an authorization response cryptogram. The issuer will send the response to the U.S. debit network, which will deliver it to the acquirer. Any EMV data in the response will be delivered to the terminal, which will pass it to the chip. The chip card and the terminal will once again interact, and the chip card will verify the authorization response cryptogram from the issuer if one was sent. This final step is not required for quick chip transactions. The AID that was used to initiate the transaction does not have an impact on the transaction response. Naturally, the terminal owner or acquirer will want to test to ensure that the U.S. Common Debit AID and DNA Shared Debit AID are being selected appropriately and transactions are routed as expected. Each of the payment networks and the Debit Network Alliance may have requirements related to certification of these AIDs. Be sure to check with your payment network representatives to obtain their specific requirements and updated certification test plans. We hope this presentation has been helpful. We realize that the concepts presented here are complex. For more information about the topics we have discussed, please refer to any of the sites listed here. The U.S. Payments Forum wishes to thank the project team and others who contributed to this presentation. To learn more about the U.S. Payments Forum, please contact us. Thank you.